Ball tossed straight up. M&M quiz 2041. After taking physics, a student is able to predict vertical motion. A ball tossed straight up rises to 2 meters. What is the initial vertical velocity with which he threw at the start? Ignore air resistance. Assume very close to the surface of the earth. So at this point, what is the initial velocity with which he threw the ball? Ignore air resistance. Assume very close to the surface of the earth. Positive y is vertically up. So is it A, 6.261 meters per second? Or is it B, 14.4 meters per second? Or is it C, 80 meters per second? Let's call that point A, and let's call this point B. We are told that it rises to a distance of 2 meters. So this delta y is 2 meters. So let's assume this is our origin. So with respect to the origin, point B is vertically above point A. 2 meters vertically above point A. When the object rises to point B, what do we know at point B? We immediately see that the instantaneous velocity along the vertical, y is for vertical, okay? So the instantaneous vertical velocity at the maximum height, what is that equal to? It is equal to 0. At the maximum height, that's how far you can go. You cannot go any further. So at the maximum height, the velocity along the vertical at point B is equal to 0. So we can call this V is equal to 0. Most of the books use V for V final, and that is equal to 0. The initial velocity along the vertical, we call it V initial, and that is what we are looking for. Anytime we are very close to the surface of the earth, we know the acceleration along the vertical. And what is that? Negative 9.8 meters per second. So we have the final instantaneous velocity along the vertical. We have the acceleration along the vertical. We also have the displacement. Based on our choice of origin, we chose point A as the origin. We are at point B, 2 meters, positive 2 meters. So now you use V final y squared is equal to V initial y squared plus 2 times acceleration along the vertical times delta y. Or you can just say V squared is equal to V initial squared plus 2 times negative 9.8, y negative 9.8. Positive y is defined as vertically up, times delta y. Delta y is 2 again. Please don't forget one basket, the other basket, the other basket. What is the final velocity along the vertical at point B? It is equal to 0. So this whole thing goes to 0. So you get 0 is equal to V initial squared minus 2 times negative 9.8 is negative 19.6. Negative 19.6 times 2 is negative 39.2. So immediately you see that V initial squared is equal to 39.2, or V initial is equal to square root of 39.2. We take the positive value for the solution. Square of the initial speed is 39.2. So what is the initial velocity? Square root of 39.2. And what is square root of 39.2? 6.261. 6.261. What is the magnitude? 6.261. What is the direction? Along positive y. And what is the unit? Meters per second. So that's what I did here. What is the initial vertical velocity? We don't know. Final vertical velocity at the maximum height? 0. What is delta y? 2 meters. What is the acceleration along the vertical? Negative 9.8. V final squared is equal to V initial squared plus 2 times acceleration times delta y. Delta y is equal to h. Delta y is equal to h. Acceleration is equal to negative 9.8. So we substitute all those numbers here, rearrange, solve. So we get initial velocity along the vertical is 6.261 meters per second. What is the magnitude? 6.261. What is the direction? Positive y. What is the unit? Meters per second. And this is George Mathew signing off for both myself and my dad. Good luck.